sure. Okay, looks like we're recording. So what the way we generally run these the trig exam reviews, the best indication of what's on the exam is looking at the review modules for the trig. So that'll be 15 through 24. There's the 3 reviews. The exam questions are taken from the topics that are in those 3 reviews. If it's not in the review, it won't be on the exam. If it's in the review, it potentially could be on the exam. The exam has 20 questions, and those are randomly chosen from the mix of questions that are in the reviews. The reviews have somewhere close to 50 questions. So out of those 50, 20 will be on your exam. Each one's a little different, but everyone sits on the same content. It just depends upon which of the questions you have from the reviews. So you're all able to share your screen. So if you have a topic or a question you want to pull up on your own system, we could do that. I've also got Alex open on my system, so we can search for questions within the reviews and get any other things that you have questions on. You are the ones that will drive this review session. So I'll open up and see if who has our first question. This way, and so first question, will we be able to print out the unit circle template to fill it in? If not, will we be allowed more than one piece of scratch paper? Yes, you can actually bring as many pieces of scratch paper as you like, and you are welcome to print the template out, the blank template out, and then complete it as the first thing you do once you get in there. I do have, let me just show you this, in the Canvas course. If you come to the very end, the week 7 module, there's where is it? Creating the unit circle. So there is a video in here. This is where it's at. There's the template right here. So this is the easiest way to get it. It's a PDF. You can download it. I think it takes the full page. So it's a big template. So you could use this one. Just make sure that's, yeah. So it takes up the full page. And again, you can have as many pieces of scratch paper as you want. Yeah, just bring it, because once you get in the exam, I don't think you'll be able to print. And so do all of that before. So print it out before, and then just show it as a piece of scratch paper, front and back. We'll see it's blank, and that was it. Okay, so let me go back. So that's the template, and in that same module, there is this video where I walk through and I actually create it, and I basically with just a counting 1, 2, 3. So that's all you really have to remember if you remember the process, rather than trying to memorize each individual numbers that go in there. But the video itself is about 22 minutes, but it's a good one to go through and practice making the unit circle, because that will be helpful. The formulas, so at the reviews, in the exam, those same formulas that are in the reviews are also in the exam. So the reviews, in fact, let's go into one. Let's see, where are they? Here we go. So what the y coordinate is, having problems in module 19. So let's maybe open up module 19. Oh, And that's the thing. Once you get in, for some reason, it put me into module 8 to 11, and you have to submit it, even if I didn't do anything in it. You have to submit it before you can go into another module. And that's because the module review are built on the same platform as exams. So we're doing reviews. Sometimes there's some resources. There aren't any of those in the exam. Let's see what's going on here. Here we go. Let's go to all right. So yeah, when you start into a review, the first two questions are, the first one is all the formulas that are provided. These are the same formulas that will be provided in the exam, just like this on question 1. And then question 2 is just the blank template. And if you didn't have the ability to print out, you could use this to at least guide you of what you put on your scratch paper, and you could make it here. Or again, you could print it out in advance and use it. And then we have all the different questions. So someone was mentioning, Lily, that you were having some problems with the module 19. Do you have a question, a particular question in mind from the review? And again, we'll kind of focus on those, because if it might be in the homework section. If it's not in the reviews, it won't be on the exam. So there's certain topics there that are not. The formulas, no, those are provided as within the system, but there's just too many. You get too many printed out things. So we allow the unit circle, because that's something you're actually going to write on and use. The formulas themselves, again, you may need to refer to them. You might want to write some of them down at the first part, but we don't allow print those out. And some of this is, I mean, I'm open, but the department didn't want the unit circle completed printed out, which I can understand, and it's because when you get to calculus, a lot of the questions you'll do in your calculus class will assume that you know those things, and you may not have access to it. Right, so you'll see 22 questions in the final exam, the trig exam, but the first 2 are not really questions. So it's a total of 20 questions that you will answer. Okay. Anything else about the exam or the process? Be happy to answer any of those, or we could get into some particular questions as we go. And one more thing I'll show you here, and again, go ahead and throw a question in the chat as you like, but also for the reviews, it's like, we'll just look at this one. If you look at the review solution videos for 19 to 22, there is the link that will take you into the reviews. And yes, you do have until May 6th. I know it sounds, usually they have some kind of a late penalty once it's, but what we try to do is, we found it is very difficult to get through this 7.5-week course. It's accelerated and everything. So we try to plan out to give you some time and give you that overlap. The official end of class is Friday. However, ASU Online has allowed us as a course to select whether we want to extend till May 6th. So that is a extension we decided is useful, and we'll take as much time as we can. So we did extend till the 6th. we plan the course to end on the 2nd because that's the way the planning is. But yes, you have for the trigonometry section all the way to the 6th. Also, if you did not finish up some of the topics in the algebra section, once you complete all the topics in the trig section, 15 through 24, you will be able to go back into the topics in the algebra if you so choose. But what I want to show you is for each of the reviews, I have provided solution videos for each of the questions. And notice we start with 3 because the first 2 questions are not really questions. And then they've also got the name of the topic that the question's coming from. So you could also copy the name, paste it into Alex, do a search on that topic, and you will be able to work multiple, so maybe when you're struggling on, you can work that one again and again and again. But all the solutions are here to each of the reviews, each of the 3 reviews. And again, these are the types of questions that will be on the exam. If they're not in the review, they will not be, that topic, that question would not be on the exam. If they're in the review, there is a possibility. It's not a guarantee because again, the exam will only have a total of 20 questions. So a lot of these questions are similar. So there's 2 for every concept. And there's a random checking and they will pull from these. So any one of these could be on your exam, but if it's not here, it's not on the exam. Okay, that's till the 6th. So that gives you over the weekend if needed. I just caution you to not try to wait until Tuesday night at 10 o'clock because there's only 2 hours left, and make sure your local time, I think East Coast you actually get longer because it's all based on Arizona time. It's midnight Arizona time. But make sure everything's working with your honor lock, just like you did for the algebra exam. Okay. All right. So I guess the only thing so far is problems with sketching graphs. I'm not sure that we'd have to find it in the top, in the questions here. The sketching the graphs might be ones that are in the homework section, but if they're not in the reviews, they won't be on the exam. Okay. Any of these, this 19 to 22, I don't think there's going to be sketching. These are all the types of questions from 19 through 22 down here. You'll also be able to use Desmos graphing calculator. That is all. Yes, there's also a practice test along with these modules. Again, I encourage you to do the modules because those are the ones in there. The practice test is 20 questions taken from there, so it gives you the feel of the length, but it does, you won't necessarily see all the types of questions that are going to be on there. You just get the feel for the length. So if you go into assignments, let's see, it's going to be here somewhere, and they don't always organize it up. So the practice test for mods 1 through 14, that's the algebra practice test. It's closed out. There's another one in here, practice tests modules 15 to 24. It has a prerequisite. And the reason that is that you have to do enough of, in fact, let's see what it is. You have to start the last review and get at least 50%. So you have to get at least halfway through the last review. And again, if you don't work through the reviews, the practice test is not going to give you all the types of questions that are there. So we want you to work through the reviews, which are similar like that. And then the practice test is a good practice just to kind of pace yourself. This is how long it's going to take to get through. But the reviews, if you work every question in the review, you will have seen every potential topic that would be on your 20 questions. Yeah, Alex sometimes gives you a calculator, doesn't, but we give you the Desmos calculator, unlimited use, anything you want to use it for. In fact, I've talked with Alex and said, can we get the calculator on everything? Because it's a pretty good calculator. If they had it for everything, we wouldn't have to provide Desmos, I guess. But that's just the way they have it programmed. Because they have ones that they want you to graph, and they don't want to. They don't want you using a graphing calculator. But we give you that tool, and you get to use it for any question you want. Let's see. Question about finding phase shift and examples in a review. If I could share my screen. Yes, please. I'll go ahead and share your screen, and we'll look over that together.
If it goes through. Share. There it goes.
Okay.
Okay, it said it requested. I don't know if it went through or not.
It did, and then I clicked on allow. So maybe try one more time. I think it's, yeah, your screen is sharing.
There we go.
So just, yeah. There we go. Okay, yeah.
Okay. So for this version of the review, 4 and 6, both questions, what keeps hanging me up on questions like this are getting the phase shift correct.
Okay.
Based on the graph, like I can see that this is a cosine, and I can see the amplitude of 4 and all that kind of stuff, but the vertical and horizontal translations, I think, is where I keep doing the math wrong, to include just basically how to find it in an equation like this.
Okay. Good. Actually, on the other one, I would say it's a sine function. And let me show you the reason. Yeah, because it's what we do is you look at where it's starting on the y-axis. Let me a little tool. So on the y-axis, it's been shifted up, but I can see it's starting at and then going up. So that would be more if we use a sine curve to have a phase shift.
Okay.
If you use a cosine, the cosine starts at the top and then would move. So you could, if you use cosine, then you'd have to use a phase shift of 2. Well, it's, yeah, because it's been shifted over by 2 because it should be starting here. So the first thing is, yeah, notice whether it starts sort of at the 0 part. This would be a sine. So sine comes up like this and down. So that one I would use the sine on. And then the other is the cosine, which goes, let's see if I get this like this. So looking, where does it start on the y-axis? And again, it could have been shifted. In this case, it was shifted up. It's not starting at 0, but it got shifted up to. So let's just walk through this, and then I'll show you the other thing. What I would do is once I have my formula, I would graph it in Desmos. And the reason I do that is then I will see if I'm correct or not. Oftentimes I'm off somewhere, like either a negative or something, and then I can make that adjustment. So yeah, I would say this is going to be a sine. It's been moved up by 2, so that up there, you're right, it's got a amplitude of 4, so that goes there. Oh wait, sorry, it's actually got an amplitude of 2 because we go from midpoint to the top. So that would be an amplitude of 2. Again, that's why, I go through and I sometimes make these errors. I still do it. But when I graph it, or when I put it Desmos, I see the result, and it's just something I have to do. And then what we've got is, again, I would say there is no phase shift. It's starting here, but to get the period, so it goes up, down, and then it's repeating here. So the period is 8.
Okay.
And then remember, that's the formula that the period equals 2 pi over b. Multiply both sides by b. You get 8b equals 2 pi. Divide by 8. So b is going to be pi over 4. Reduces down. So this should graph out pi over 4x, no phase shift. And if we graph this, we should be able to verify that right here, that that's exactly what we got.
Okay.
And if it's not, then we would know to make adjustments in this until our graph looks the same. When you're doing this, the other thing I do is you can set the window in. In fact, actually, I'll do this once. I'll share my screen back, and I'll show you some tricks I've found in Desmos that are helpful, especially for getting when the bottom is like pi over 2 or pi over 4. So those help. But does that help?
It does. Yeah. If we could
Okay.
do number 4, just to kind of do it in reverse.
Okay, you got it. So let me clear off this. And what I would do at number 4 is I would go ahead and graph it. I mean, you might be able to see the amplitude's going to be 1 because it's in front. You could
Right.
get the period because you've got the b value. I mean, you could do this all analytically, but you could also graph it. Oh yeah. And the phase shift, because there's 2 ways of looking at the phase shift, and that's whether there's a parenthesis. So if this was 3x plus pi, it's sort of different. What we have to get the phase shift is we have to get it into this form. But this is, so if we've got, so the way, and then I'll graph it, and that's going to be actually an easier way to find the phase shift. What we have to do, we have to get this in the form where it's x plus something, and then there's a factor on the outside. So this would be our b, which the 3 is in front of the x. Well, if you factor 3 out of pi, what you end up with is pi over 3. And the way you do is if you multiply back, you get 3x. The 3's will cancel. You get 3x plus pi.
Okay.
And so this is going to be our phase shift, pi over 3. The way you can see that is if you'll go into into Desmos. In fact, since
Right.
it's here, you want to go ahead and do that?
I can
Open up a
open
new
one.
tab.
Yeah.
Let's open up one more tab.
That window out of the way.
Stuff out of the way. And then just graph that it was 1 minus sine or negative 1 minus, yeah, that's it. And then it was parentheses 3x plus pi.
And then we can just type pi for that, right? And it'll fix it.
Right, yeah. And then what you're going to see is, wait. It shifted down, it flipped. I don't see a phase shift. Oh, because it's a phase shift. Let's see. Do this for me. If you'll click on the wrench over here,
Oh, yeah.
and to your x-axis, change that to go from negative 4 pi to positive 4 pi. You could just, yeah, and you could just, there you go, and put that as 4 pi. So we got, okay, still isn't quite doing. What you can do is in next, one more thing, next to, at the wrench on the step, if you can go in there and make it pi over 2.
On the which part?
Where it says step.
Oh, yeah.
Yeah, put that in as pi over 2, pi over 4, something like that. And what you'll see is now your labels down here are in
Okay.
terms of pi. That's one thing that I find it very helpful. A number of students have found that very helpful. So knowing
Okay.
that part. Um,
And then those still relate to the circle, so that every 90 degrees or 1 pi for half a circle.
yes,
Okay.
yes. So it helps you getting it in terms of the pi.
Okay.
Let's see. There is something. Oh, one more thing. The reason this doesn't look quite right to me. Go back to the wrench. There's another thing we need to check on is we need to make sure, yeah, we are in radian mode, so that's here. So be careful sometimes if we got switched over to degrees, it might not come out right or something. So this is where you switch from degrees depending upon the question. Let's see. But I'm I'm a little baffled. I'm expecting pi over 2. There's a difference between sine and cosine is pi over 2.
Okay.
Just a moment. Let me look something up real quick.
Negative 1 sine ax plus pi.
Phase shift is there. Let's see. I get that backwards. So phase shift is the C once you've gotten it out. Yeah. But from what we were doing, this phase shift is the way here is it should be factor out the 3, so you get 3x. Where did the tools go? Sorry about that. But I would say that this happens. Anyway, I would graph it, and what I'm expecting is this graph should have a phase shift of pi over 3. Let me try something.
Would it matter if it's typed in with it factored with that 3 already pulled out?
Go ahead and do that below, and let's see if we get the same graph. We should get the same graph. So -1 minus sine
And then 3
parentheses.
on the outside?
Well, actually, there's a parentheses and then a 3 on the outside.
Oh,
So
that's
there'll be
right.
two. So
Mm.
3 parentheses x plus pi over 3. And we're getting
Oh,
the same graph. Um,
okay.
this should be minus sign, subtracting 1. So that was moved it down. But it doesn't. See, if you have a negative on the sign, it should also be a reflection. So it should be going downward. Um, I'm going to graph it on. For some reason, it's not looking like what it should. Let's see.
Is Desmos picky about y equals, or does that matter?
You could try that, but if it graphed it should be okay. Here's 3x
Okay.
plus pi. Yeah, I'm getting exactly the same thing. But if I do pi over 3, then I get a phase shift. Shift of negative 0.5. Yeah, you have to have it factored. Well, if C over B represents the phase shift. Okay, so we factor it out. Okay, that's the only thing that's making sense is that the phase shift is C over B, which actually favors this first form. So the phase shift is pi. And the reason we don't see that is when it gets shifted by pi over 2, it gets back to where it started. So it's basically got shifted twice. Um, and you can see at pi it's repeating because of its period as well. But it does have a phase shift of pi.
Okay.
So it's going to, yeah,
Okay.
you take the
That makes
C
sense.
value divided by 3. So, okay,
Okay. Now that makes sense.
okay, very good.
So then, yeah. Okay. Okay. That helps. Those are all of my questions right now.
Okay, wonderful, wonderful.
I'll hand it back over.
Thank you. There we go. Okay. Can I go over simplifying the identities question next? Wait, so how did we find the phase shift again? Now let me share my screen. So what I looked up is, what's the setup? And you got to be careful, I guess, when you go on the internet. I find sometimes they're not always accurate. Um, but in this case, usually we put B here for the period, not A. In fact, that's what they're using. So once you factor it out, though, um, the phase shift itself is C divided by B. So if we didn't factor it at all, right, if we left it as 3x plus pi in this form, this number here is our phase shift because we're taking it and adding it to the x. It actually it moves it in the negative direction by pi. When we factor it, we factor out the 3x plus pi over 3. Then to get the phase shift, you take C, which is pi over 3, and then you divide it by B, which is 3. Okay. And when you do the math here, the 3's are going to cancel. This is pi over 3 divided by 3, which means you flip, invert, and multiply. That's pi over 3 C over B. You factor that out, and then you're going to multiply it back. This is going to give us pi over 9. And that's also that's what I like to do is if we could just when you graph it, the best way to tell the phase shift is to graph it, and in this case the original, and you can see that it's starting right where it should start, right? Sine always starts at 0 and goes forward, and so it has it's got a phase shift of pi here. Pi over 6. It's got a period mentioned there. Okay. Let's see. Simplifying identities question. Do you have a question number for one of the reviews? Identities. I think those are review 23. Have to get out of this one. Something like this, Durga. Okay. Use algebra and the fundamental trigonometric identities. Your answer should be a number, or use a single trigonometric function. Again, with these, one of the things I might suggest doing first is graphing, and then sometimes, because it might simplify to something as simple as sine or cosine, and if you look at the graph, sometimes that helps you. Okay. And again, since we do have it, cotangent x secant squared x cotangent. Okay, so y equals, we'll do that. Cotangent, you can pick up these functions with the keyboard and you can go to functions. And then we've got our cotangent here, cotangent x, secant squared, secant x. And when you do secant squared, you're actually squaring the whole function. So you don't put it on the secant, you put it out here. And it has to be outside the parentheses, not inside, otherwise it would be the secant of x squared. And if you want to really be safe, you put a full parentheses here. So we're squaring the secant. And then we're going to subtract cotangent minus cotangent of x. And it's not necessarily helpful, but I see what I've got is maybe a cotangent or a tangent, or I didn't get a sine or a cosine. Some of these will simplify to sine or cosine. What you could do is once you get your answer now, that's the other reason to having this set up, we'll put our answer and it needs to look exactly like this. Okay, so let's go ahead and simplify. So cotangent, secant, and cotangent. One of the things I do is you change everything to be in terms of sine and cosine. Cotangent of x is cosine x over sine x. It's the reciprocal of tangent. And secant is going to be 1 over cosine. The way I remembered the difference between secant and cosecant is the cos can't ever go together. So the cosine cannot go with the cosecant. So the cosecant is 1 over sine. We don't need it in this case, but then I would substitute everything in. So we've got cotangent x is going to be cosine x over sine x times secant squared. Secant is 1 over cosine, so that'll be 1 over cosine squared x minus another cotangent, which will be cosine x over sine x. And they want us to get it down to either a number or a single trigonometric function. So what we do next is we can cosine one of these cosines, so it was cosine squared, those cancel. So now we get 1 over sine x cosine x minus cosine x over sine x. What we need to do is get a common denominator to be able to combine those. So common denominator is sine x cosine x. So I take this second part and I multiply it by cosine x over cosine x. It's a value of 1. So now we have 1 minus, actually, put it this way, cosine squared in the top, sine cosine in the bottom. Since they have a common denominator, we can combine these into one fraction. And then you have to recognize that 1 minus cosine squared is a Pythagorean identity. And again, if we went to the front, we can see. Well, it's a version of sine squared plus cosine squared equals 1. If you subtract cosine from both sides, you get the identity that sine squared x equals 1 minus cosine squared x. Where were we? We were on 5. We were on 3. Should have paid attention to where we were. And when maybe we were on 2, or were we on 9? Forgot what question we were on. If I don't find it, the very last one. There it is. Okay. So we're going to make that substitution here. That 1 minus cosine squared is sine squared x over sine squared x cosine x. Oh, no, sorry. Bottom only has one sign, so just sine. And so now the signs can cancel. The sine cancels with 1 in the top. We're left with sine x over cosine x, which is tangent x. So you have to know your reciprocal functions. You have to know your Pythagorean when you've got your Pythagorean identities. And so the final one is tangent x. And if we look at the graph, that's what I know it was probably either a cotangent or a tangent. I wasn't, because that's what and so what we can do now is we could actually put in y equals tangent x, and we see that it's right on top of the previous one. So we know that's the correct answer. Okay, so yes, it's a bit to get through, but always check your answer. If the original function that we were given and your final answer, if you graph them and they are not on top of each other, they're not equal, they're not the same, they're not an identity, they have to be the same. So then you could catch maybe where you made an error on that. Is that helpful? Okay. Almost 6:30. Other questions? Hasn't been a lot. I also have review from last session, so I will post that as well. The last question, certainly. 17. So these are double angle, and so we're given what tangent is, and then we're going to need to figure out what sine of 2x, cosine of 2x, and tangent of 2x. We'll go and get the formulas for these, and I'll do that first just so we know what we're needing. So I'm going to come back here, and there's our double angle formulas. I'm going to write them over here because then they'll still be there when we need them. So sine of 2x is going to be equal to 2 sine x cosine x. Cosine of 2x. Now with cosine, you have 3 choices. You could use any one of these. I'll just go with cosine squared, sine squared. Minus sine squared x. Tangent has 1, so tangent of 2x is equal to 2 tangent x over 1 minus tangent squared x. And then now what we're going to do is we're going to go back to that question. We're given a value for tangent. So we could actually go ahead and do tangent 2x right now without anything else. We know tangent x is negative 15 over 8. So using that formula, the tangent of 2x is going to be 2. Got some stuff on top of there. Tangent x is negative 15/8 over 1 minus negative 15/8 squared. So notice I'm just plugging in for the tangent there. The 2 will cancel with the 8, making it a 4. Negative 15/4 in the top. The bottom will go ahead and square. 15 squared is 225. 8 squared is 64. It becomes positive, so we've got 1 minus 225 over 64. In the denominator, you can always rewrite 1 with a common denominator as 60, in this case 64 over 64. So the denominator is 64 minus 225. It's negative 161 over 64. We have a fraction over a fraction. We go ahead and divide. So that's negative 15/4 divided by negative 161 over 64. We invert and multiply negative 15/4 times 64 over 161. The minus on it, minus and minus, we're going to get a positive answer. 4 goes into 64 16 times. And so we're going to get 15 times 16. Negative times a negative is positive. 15 times 16 is 240 over 161. So that is the value that goes in there. Now, how are we going to get cosine and sine? We have to take this value. Remember that tangent x is equal to sine x over cosine x. Sine x can't be equal to 15. And also do this, that tangent. So tangent is opposite over adjacent. It's negative, so it's either in second or fourth quadrant. And make a triangle over here. Oh, it tells us it's in the second quadrant. Tangent is opposite over adjacent. Here's the angle for here. The opposite would be 15, so that's a y value. The adjacent would be 8. Since we're in the second quadrant, the x coordinate would be the negative 1. And then what we need to do now is we need to calculate the hypotenuse, is going to be 15 squared plus 8 squared. The square root of that gives us the hypotenuse. Remember, a squared plus b squared equals c squared, where c is the hypotenuse. 15 squared plus is 289. You take the square root of 289, you get 17. It's a good number, nice friendly number. So then, what is cosine? Well, let's start with sine. Sine is opposite over hypotenuse. Opposite over hypotenuse. And cosine is adjacent over hypotenuse, so it'll be negative 8/17. And then we plug those into the formula. So sine of 2x will be equal to 2 times the sine of x, which is 15/17, times the cosine, which is negative 8/17. So we multiply that all out, and we're going to get negative 2 times 15 times 8 is 240. And in the denominator, we get 17 times 17, which is 289. And so that goes right up here. And then to get the cosine of 2x, we use this formula. So we've got cosine of negative 8/17. We square that. I should change colors so I can minus 15/17. And so both going to be negative, so the answer will be negative. 17 squared is 289, so that's our common denominator. This is 64. Wait a moment. No, a little too fast. Go ahead and do this. When we square this, this negative is going to become positive, right? So 8 squared, we get 64, positive 64 over 289. Square the bottom. Here we're going to subtract 15 squared is 225 over 289. Common denominator is 289. 64 minus 225 is negative 161. That's someplace else. Okay, how was that? Helpful? A lot involved, right? Yeah. But when we have these double angle formulas, notice they all reduce down to single sines and cosines and tangents. So the way these are, they will always give you one value. Sometimes you can get, like I said, the first one we were able to do without any special calculations, just using the number they gave us, plugging it into the formula. But then you're going to need to use this this information that we're in the second quadrant, setting up a triangle, opposites and adjacent sides, and finding the hypotenuse. And then that allows you to find the sine and cosine, which then allows you to use the formulas to get the rest. Okay. 6:30. Do we have any more questions or concerns? Okay. What have you got for us? One more question.
So this review, there's a couple of these examples of finding exact values.
Uh-huh.
And I think I just keep getting hung up because the last time I went through this review, I felt confident and all three of them were wrong. So I don't know what I'm
Okay.
missing.
Which one? You want to share it with us,
Uh,
or do you have, or if you just give us a problem or something, we could work through those.
did the screen share go through this time?
Let's see. Let me stop sharing first, and then I think that'll should be able to go there directly. I do have it set that anyone, yeah, multiple advanced sharing. So yeah, everyone should be able to. Okay, good. See it now, and then just
Okay,
share
so
your.
yeah. If you can, if I shared the right one, I don't know if you can see that. Question 12 is arctan of tangent 7 pi over 6.
No, we don't see that. I just see your Zoom window.
See if I can do that again.
There we go.
Okay.
Okay.
Yeah, so there's three in this review, and they're all slightly different, but I think they're all the same type of question.
Right.
I just keep getting them wrong.
So all of these are okay. So this is an inverse sine. Part of the problem is maybe with, oh, I know what it is. You're probably getting one of the right answers, but you also have to consider the domain for, here we go, the domain for sine. So when we have an inverse sine, the answers for the angles that come out of here are going to be from negative pi over 2 to positive pi over 2. And so the first quadrant has positive sine values, the fourth quadrant has negative ones, but these angles here are given as negative angles. And sometimes if you just like plug it in a calculator, um, it'll give you the wrong quadrant. Write your answer in radians in terms of pi. So what this is saying is the inverse sine is negative 1/2. So that's one of our special angles. And which one of the angles has a y value of, so there's x coordinates here, has a y coordinate of negative 1/2. I think the sine goes from being 0, so it's going to be 1/2 here. It'll be square root of 2 over 2, and then the 60-degree angle would be square root of 3 over 2. So um, it's kind of a mess. So we've got the angle of pi over 6, negative pi over 6, negative pi over 4, and negative pi over 3. The coordinates for the angle negative pi over 6 on the unit circle would be square root of 3 over 2, comma, negative 1 over 2. Coordinates for pi over 4 are going to be square root of 2 over 2, square root of 2 over 2. And the last one is going to be 1/2 over square root of 3 over 2. So we would say that the sign of negative 1/2 would have a value of negative pi over 6. There is a way that we came up to do it with Desmos, because if you don't know exactly, your unit circle, this one we're doing. Let me see if I can replicate that. I think I equals for sine of negative 1/2. Okay, yeah. Let me share. Actually, let me have you do it with your Desmos. Go to your Desmos, and I'll clear out my stuff if I can find. Can't. And what you're going to put in there is y equals inverse sine of minus 1/2.
Just close it. Okay.
Yeah. And you'll see there's a line now. It gives you a decimal equivalent there in the answer, but click on the graph on the line, especially that point, anywhere on there. Notice it gives you the answer negative pi over 6.
Right.
And that's a workaround that a student came up with last session. I didn't figure that part out. Somebody else did, a little bit brighter than I was.
Okay.
Okay. So with those, you can, if you just put it in as y equals, you will, if it's got a pi value, something like pi over 6, whatever, you'll get the right answer right here. Dakota.
Okay.
I was going to ask if does that work throughout, like the other problems that he had pulled up, like all the inverse signs, like,
It does.
okay, cool.
And that's why I like being ability to use Desmos, because Desmos is the only calculator I've seen that gives us the answers in those in pi, like pi over 6 and pi over 4, rather than just decimal. The TI-84 calculator only gives you decimals. And I don't
Okay.
know
And the arctangent is the same as the inverse?
It is. It's a different way to write inverse tan to the minus 1. So arctan. So if you see arc cosine, arc sine, they're the same thing as the inverse. And yeah, if you just enter those in to Desmos, and then it'll graph it as a straight line because it's a number, but typically it will give you those values. And I apologize for not being able to clear my mess. There we go. Tools.
Yeah. Okay.
Yeah, and it's the y value that you'll get. Yeah, and it puts it in the right domain and everything. So
That's awesome.
yeah, and like I said, it's really hard to explain it when you're just trying to do it sort of abstract of how to get at it. But again, last session, someone came up with this, and I said, this is a nice way to use our tool.
Excellent. Okay, I am done.
Okay, wonderful. Thank you so much. Thank you all for coming. Any questions? If you run into something else down the road, I'm planning just to be home working over the weekend even. So if you email me, we can set up a quick session. You do have until Tuesday. But again, if you want to get it done and have other things, you can get it done anytime you're ready. But I'll be available over the weekend as well. So if there's nothing else, we'll go ahead and close out.
Thank you.
Thank you very much.
Thank you for the session.
Thank you so much. Thank you for coming.